The physics of harmonia, the music of the spheres. For centuries, people have looked to mythology to find order in the world. Consider the ancient Greek goddess Harmonia. She was a singular figure born from the union of Aphrodite, the goddess of love, and Ares, the god of war. Harmonia was the personification of concord, of order, and the exquisite balance of forces that are seemingly at odds. Her wedding was so significant that every god on Mount Olympus descended to celebrate. This goddess is where we get the name for the musical concept of harmony, the fitting together of sounds into a beautiful and pleasing whole. But the connection between mythology and mathematics runs much deeper than just a name. To understand how this works, we have to look at the physics of sound. Sound is ultimately made of pressure waves traveling through the air, and we experience what is called frequency as the pitch of a sound. However, no simple vibrating object like a string or an air column makes just one pure note. Instead, they create a complex blend of sounds. Imagine a vibrating string. The main sound you hear is the fundamental frequency, but at the same time, the string is also vibrating at 2 times that frequency, 3 times, 4 times, and 5 times, and so on. This series of vibrations is known as the harmonic series, and these extra tones are called overtones. The specific combination of overtones is what gives an instrument its unique character, its timbre. This perfect mathematical stack of frequencies is the very foundation of all musical harmony. Now, let us connect this back to why some combinations of sounds are pleasing while others are harsh. This gets at the ideas of consonance and dissonance. Consonant intervals like a perfect fifth or an octave sound good because the mathematical ratios of their frequencies are very simple. For an octave, the ratio is exactly 2 to 1. For a perfect fifth, it is 3 to 2. These simple whole number relationships mean that the harmonic series of both notes line up cleanly with each other. They do not clash. On the other hand, dissonant intervals have very complex frequency ratios like 16 to 15. Their overtones are constantly conflicting, creating that tense sound we associate with dissonance. So it turns out that what sounds beautiful in music is built directly on simple mathematical relationships. This incredible discovery brings us to one of the most influential figures in ancient thought, Pythagoras. He was a mathematician, but also a mystic whose followers believed that number was the ultimate principle ruling the entire universe. And it was Pythagoras himself who is credited with discovering this definitive mathematical connection to harmony through a truly remarkable experiment. He used a simple instrument called a monochord, which is just one string stretched across a sounding box with a bridge that can be moved. By changing the position of that bridge, Pythagoras found that he could create different notes. He started by using whole integer proportions of the string length and listened to the resulting sounds. He found that when he stopped the string at exactly 1/2 of its length, he produced an octave, which, as we know, has a simple 2 to 1 ratio. When he set the bridge at 2/3 of its length, he created a perfect fifth, which has a 3 to 2 ratio. And at 3/4 length, he heard a perfect fourth, which is a 4 to 3 ratio. This concrete and repeatable experiment proved a truly profound idea. Mathematical relationships, the kind involving simple whole numbers like 2, 3, and 4, directly structure the world of music. But for Pythagoras, this was only the beginning. He believed that the same logic must apply to everything. If simple whole numbers defined harmony in music, then they must also define harmony in the cosmos. He envisioned the universe as a unified whole, an ordering he called a cosmos, and he applied these same harmonic principles on a truly grand scale. This led to his concept of celestial harmony, the music of the spheres. Pythagoras proposed that the planets and all celestial bodies moving in their perfect circular orbits through the heavens must generate their own unique sounds, and the specific distances of their orbits from Earth, their speeds, and their sizes could not be random. They must all be determined by the very same mathematical ratios that define consonant intervals in music. This celestial symphony is the Musica Universalis, the divine and unceasing harmony of the universe itself. Ancient thinkers believed that this music was always playing, but it was either too pure or simply too constant for human ears to register. It is the true source of all cosmic order. So, when we tie it all back together, we can see a remarkable arc. We started with the mythology of Harmonia as an inspiration for finding balance and concord in the world. Then we explored the concrete physics of sound, showing how all complex tones are built on the harmonic series, and how simple, whole number frequency ratios create consonant intervals. We learned how Pythagoras codified this entire connection with his monochord experiment, proving that number structures musical sound. And then he made his ultimate leap of imagination, applying these very principles of earthly music to the entire cosmos, creating a unified vision where harmony and number connect the micro world to the macro world. In the end, we can reflect on a powerful idea. The ancient world did not see music and science as separate pursuits. Instead, they understood them as two deeply intertwined keys that could unlock the fundamental order of all existence. So the physics of Harmonia is not really about music theory at all. It is about uncovering the mathematical and harmonic resonance that binds the mythic goddess to the physical laws of a vibrating string and to the very structure of the cosmos itself. For centuries, the music of the spheres was dismissed as a beautiful, poetic metaphor, a relic of a pre-scientific age. But today, the materialist model of a universe made of silent, colliding rocks is being replaced by a much more musical reality. Modern frontier physics is revealing that the cosmos is not a collection of objects, but a vast web of interfering wave functions. From quantum field theory, which tells us that particles are simply localized vibrations in underlying fields, to the discovery of fuzzy dark matter, we are realizing that the universe behaves exactly like a giant resonant chamber, vibrating in a mathematical harmony that Pythagoras would have instantly recognized as a cosmic fundamental. In 2023, the NanoGrav collaboration announced the detection of a background hum permeating all of space-time, a low-frequency chorus of gravitational waves that sounds like a cosmic choir. Astronomers have discovered that planetary systems like TRAPPIST-1 exist in near-perfect orbital resonances, with their years synchronized in the exact musical ratios of the octave, the fifth, and the fourth. We are finally moving past the image of a cold, silent vacuum and returning to the Musica Universalis. Pythagoras wasn't just dreaming. He was hearing the true frequency of reality, proving that whether we look at a vibrating string or the rotation of a galaxy, the universe is, at its heart, coherent music.